P the Bath G, everyone, and we are on either the fourth or fifth, I want to say the fifth lesson on the big three in AP calculus. We have talked about in detail the limit. There's a big three called limit, derivative, and integration. We've already dealt with the limit. We did a few lessons on that, and now we're talking about the derivative. We've done, to my knowledge, one lesson on the derivative, and now I'm working on a second and then a third lesson on the derivative, and actually it's going to go into other lessons on the derivative, especially when we start talking about the first and second derivative. The derivatives that I'm showing you here, if I do a derivative on a function one time, that's called the first derivative. If I do a derivative on that derivative, it's the second derivative. Okay? We'll get to that later because I want you to understand what the first derivative does, what the second derivative does, and I want to do that separately from just finding derivatives right now. So we did talk about the power rule, we talked about the product rule, and now we're going to talk about the quotient rule in this problem, and then maybe a couple of lessons on the chain rule. The chain rule is probably, all of them are important, but the chain rule is just really, you just need to know that chain rule. And so I can remember struggling with the chain rule when I first started doing calculus, but now it's just so much easier nowadays. But I've done a lot, I've practiced on it a lot too. And so you're going to need some practice. When you work on these derivatives, you're going to definitely need some practice. Well, let's take a look. We're dealing with a quotient rule, so I'm going to give you a quotient to work with. Here it is right here. Alright, so let's put this up here. Okay, g at x. Now, quotient is a ratio. Okay. Alright, that's what we're going to work on. Let's do this one here. 5x cubed plus x squared over x squared minus 4. Okay. When we talk about the derivative dealing with the quotient rule, this is a quotient, okay, a over b. Alright, and so what we want to say, the numerator is high and the denominator is low. So I'm putting that there for a reason. Let me get a better writing pen here. Okay, marker. Alright, let's take a look at this now. The derivative. Okay, so let me see if I can put this on the side. The derivative of g, we call it g prime at x, is equal to low times the derivative, if it's with respect to x, of high. Oh, I don't know if I'm going to have room. I know I'm not. So let me scoot it over. Okay. So g prime at x is low times the derivative of the high. Alright, I'm going to just put a derivative of the high minus high let's make them both small case letters, minus high times the derivative of the low divided by the low squared. So we say it this way to kind of help you understand it. Low d high minus high d low. You see what I'm talking about? Low d high minus high d low divided by low squared. So let's take a look at this, okay? And I'm not going to expand anything too much. So let's see how this works. Alright, I'm probably going to have to flip this over. So let's go ahead and look at it. G prime and X, I'm going to put it down here. Now, that equals low, here's your low right here, x squared minus 4. You're going to put it up here in the numerator. See that? The low is in the numerator, so put it up there. Low derivative of the high, which is the high, okay? 5x cubed plus x squared. Alright, it's going to be a long, drawn out problem. Now, in the product rule, it's plus, but in the quotient rule, it's always minus. So let me extend this out a little bit. Minus high, low d high minus high. So let's copy that down. I'm just going to kind of put that in a bracket. 5x cubed plus x squared high d low of the low, which is, oh boy, over the low squared. Okay, low squared. X squared minus 4 squared. Alright, so we squared the denominator. So what I like to say about this is, sometimes you may not always remember low d high minus high d low. Okay, you like to memorize this if you can. Okay, right there. Alright, so I always like to look at it this way. This is the way I memorized it without learning low d high, high d low, and so on. I said if you move this up here, you've already done something to it. Don't do something to it twice. It's like a chess piece. You move it only one time. Once you move that piece, don't do another move with it. It's another person's move now. So this one that's been sitting up here doing nothing, you're going to go ahead and take the derivative of that. So something is done to both of these. Bring this up, take the derivative of this, minus now the one that you you've already taken the derivative, so don't take the derivative this time, and then now take the derivative of the one that you brought up. And just remember, you're going to square this denominator. But I do like the low d high minus high d low all over low squared. Keep in mind it's always minus. Alright, so let's take the derivative. Let's go ahead. I'm going to have to flip this over, I'm sure. So g prime at x. I hope I can put it all over here. So low, just write it down. Do nothing to the first part. Now, let's get this derivative. Remember the product rule. 3 times 5 is 15. 15x. Remember, you're going to take 1 away. 3 minus 1 is 2. Now this is a 1 here, so 2 times 1 is 2. And then x minus 1, 2 minus 1 is 1, so x1, which is just x. Alright, there's that. You don't need the 1 on anything really, okay? You don't really need the times sign. This is already times, but side by side. Minus high, alright, so high is this one, 5x cubed plus x squared, okay, put that in parentheses. Do not put the parentheses around there, okay, leave that parentheses around there, times the derivative of the low, which is again 2 times 1 is 2, x to the 1, always reduced by 1. And remember that a derivative of a constant is 0 from the previous lessons. And then this is divided by, all divided by low squared. We don't need the 0. So really it's just this. Okay. But we do want this minus sign, this away from the minus sign. So then you can distribute this and distribute that. I don't want to get into the arithmetic part of it, but this is done by the FOIL method. This is done by just distributing the 2x over the 5x cubed and the 2x times the x squared, and then you have this right here. So really and truly, this is the idea of the quotient rule. I'm not going to do the arithmetic, although I did do the arithmetic down to a point. No, I didn't do any more than that. So, alright. Everything looks good. So, once again, on you using the product rule, there are times that you don't need to use the product rule, okay? Sometimes you don't, but in this particular case, yes, it's a good idea to use the product rule. Product times the quotient rule. Quotient rule. This is a quotient. And there are times when the denominator can be brought up to the numerator. Okay, say it has an exponent of 5. You can put up here a negative 5 up here. And then you can make a product rule. A lot of people like the product rule better than the quotient rule. But I did want to show the idea behind the quotient rule. And so I know it's a lot here to digest. But here's the low, here's your denominator. Low d high. I did take the derivative of the high. 15x squared plus 2x. There's that derivative. Minus high. And then this derivative here is just 2x. Don't need the 1 here. And then over low squared. All over low squared. Again, you would have to probably, if you want to see a final answer, you'd have to distribute this using the FOIL method, or if you know how to do it without the FOIL method, you can just distribute that and then distribute this over here, collect like terms, and see if there's anything that can be reduced here. And that may be that's true, but we're just going to leave you with this idea here so you can get this idea. Again, I'm not doing the arithmetic here. You can do that on your own. I'll probably do it and see what the outcome looks like and show you that outcome on the next video. But that's the basic idea behind the quotient rule. So the next derivatives that we'll do is we're going to work with the chain rule, and I will probably I have 2 examples of the chain rule. Ever how long that lasts, I'm hoping I can get 1 lesson out of that, and then start talking about, I don't want to get into integration just yet, but since we're on the derivatives, we can talk about when we use the first and the second derivative. What are they for? Okay, I thought, and then I'll get into integration and when to use integration. So I don't know how many more videos I'm going to have. This makes my 203rd video right here, I do believe. So anyway, be that as it may, that's quite a few videos on this calculus material. So you got a load of stuff to look at that you can just look at on your leisure. But this big 3 is going to really help you. Okay, if you pay attention to the big 3 and just learn how to do the idea behind it, you're already going to be heads up or ahead of the rest of the class. And then you can show your friends and classmates how to do what you've learned from me. Okay, anyway, this is KP the Math G signing off. Ladies and gentlemen, if you want to subscribe, please do so. I did pick up another subscriber. I'm proud of that. But again, it's not about me, whether you do or not. Would like to see a comment occasionally. If you want to make a comment, please do so. If you like to hit that like button, please do so. But again, none of this is about my glory. It's about you learning how to do this. Alright, anyway, that's all I have for now. And so we'll talk about the next lesson will be on the chain rule. One of my favorite lessons. All of these are really good, but I like the chain rule. And if you learn the chain rule, you can do any of them, I think. It is a little different. KP the Math G signing off. Ladies and gentlemen, have a great day. I like doing that. That's called a signature ending. Right? So I clap like that. It may look silly, but still, I like doing things like that. Okay, we're gone.